No need to copy it down. How would you solve that for x? That's what I want to know right now. How would you solve that for x? 3. How would we solve that for x, Spence? Okay, which terms would you cross multiply? Go ahead. I know this is very simple, but it's going to get to my point. Okay, you would multiply the 3 with the what? Okay, let's stop right there. We're going to stop calling it. We're going to multiply 3 and the 5. Those two have a special name. Okay, when you multiply this way, going downhill, these are called your extremes. Right? Those two numbers in a proportion are called your extremes. All right, those are called your extremes. So if I go over here, A and D, those two values are called your extremes. And what other two values would you multiply, Spence? X and 2. These are called your means in a proportion. All right, so when you cross multiply values, those values have names, means and extremes. If you want to know, I know this is really elementary schoolish, but I always remember the extremes because I'm going downhill, extreme downhill skiing. That's how I remember where the extremes are. I go downhill skiing. Okay. And then over here, B and C, if you guys are taking your notes here, those are your means. Spence, going back to you. You said multiply them, right? And then what do I do with them here when I multiply them? Set them equal to each other. Anybody know the answer when I multiply? It's got a special name. When I multiply two numbers, the answer is called, that's adding, product. So what did we just show here? And here's our theorem for today. The product of the means is equal to what? What did we set the means equal to? Finish it for me. The product of the means is the same as 9. What did I multiply here? The extreme. So product of the means equals product of the extremes. Quickly before we hop into the proof. I can't cross multiply unless I have a what here? What did I put up here originally? What was that called? Just 3 over x equals 2 over 5. That's called a, before I multiplied 6, what was that called? 3 over x equals 2 over 5. That's a proportion. So I need a proportion. And Friday we learned I can't have a proportion unless I know what about the triangles. 6 again? They're similar. So everyone see, this is going to be 3 steps eventually. Prove the triangle's similar. Set up a proportion like we did on Friday, and now we can cross multiply today. That's what we're going to do. Triangles, proportion, means and extremes. Here you go. Look at the proof statement in number 1. Everyone see I multiplied means and extremes here. I'm multiplying sides together. ER, AD, TE, and DT. So we say to ourselves, all right, this is going to be a means and extremes problem. I need to prove triangles similar then. Find me the triangles. There's way too many triangles for me to just guess. What did we go over on Friday? How should I figure out what triangles to prove similar without guessing? What can I use? 6 again. Nate Dogg, you're on fire. Proof statement. Let's go ahead, Nate. Give me a side in the proof statement. Give me a segment. ER. Everyone look at ER. Can everyone find a triangle that has ER as a full side? Name it. 5. Name that triangle that's got ER as a full side. ERT. Abbott, while we're here with you, name another side in the proof statement. AD. Thank you for picking AD. Everyone see AD. How many triangles do you see that contain AD as a full side? Everyone see 2? So I got to keep going. I don't know which one it's going to be. So keep going. Abbott, give me another one. Go, you can give me it. Go ahead. DT. You were going to give me TE though, right? All right. Okay. What did you notice when you gave me TE? It's 2 triangles. It was already part of the triangle we have, right? Yeah. So what's the last one? DT. So we had AD and DT. Everyone see the triangle? What triangle is the second one then? Here you go, 7. ADT. So AD belonged to 2 triangles, so I kept reading the proof statement. So those are the 2 we're going to prove similar. What's the only method we really have in a proof? 6, again. Angle. Everyone ready to find 2 angles for me? And I think we've done something similar to this, no pun intended. A proof like this. Those 2 are equal, and then I got right angles at TER, and I got right angle at ADT. You're welcome, by the way, that I just told you that they were right angles. Makes your life a little easier. All right, where do you want to go in the proof? We got to prove them similar. 8, where do you want to go? I need angle here.
Yeah.
So I need a pair of angles somewhere.
Angle DAT and ETR.
ETR. Why? What do I already know the 2 triangles have from the givens?
Right angle.
Right angles. So just say there.
Oh, the right angles are congruent.
Yeah, and you got your 1A, right? Just say the right angles are congruent. Let's start there. TER, congruent to angle ADT. All right angles congruent. There's 1A. And then I'm sure they gave me the triangle was isosceles for another reason, right? They just didn't give us that without us wanting to use it. Where's the other pair of angles going to come from here? 3, Spence?
ART is congruent to ATR.
Good job. Right there. Those 2 angles are going to be congruent to each other for a reason somebody else is going to give me. So angle, I can say angle R here. Congruent to, can't say angle T though, ATD. How's young Spence know that? Why are those 2 equal? 1, Anna?
Isosceles triangle implies base angles congruent.
There we go. Yep. And some of you maybe use this one. Either one's acceptable in a triangle. Congruent angles across from congruent sides. All right, great job giving me the angle. Now give me a nice similarity statement. We now know the triangles are similar because we have both pairs of angles that we need. Give me a good similar statement now. Here we go. 12, triangle.
Triangle ERT
Okay, ERT, got it.
is similar to triangle DTA.
Good job. Yep. Make sure you guys have the tilde there, not a congruent sign. Make sure you have the tilde. Angle, and I'll stop right there. We're all good so far? Everyone caught up? I am not going to go to means and extremes now. What do I need to cross multiply? I still need a what, Spence? I need a proportion now. So I can cross multiply. All right, how do I build this proportion? Go back to your proof statement. All right, let's put ER. What do you need to multiply ER by? According to the proof statement, you need to do ER times 12? AD. So where should I put AD if I'm cross multiplying, right? I got to cross multiply ER with AD. I can only go there. I can't go on the bottom. I'm cross multiplying those 2. And then TE and DT can go at any of the other 2 spots. So everyone see how I set that up? I got to cross multiply those 2. And then from Friday's class, why is that true? Why are the sides in proportion? After I just proved the triangle similar, why are those sides in proportion? 12?
CSSTP.
And there's Friday. And now we take it one more step. Oh, now you want me to cross multiply? You got it. ER times AD equals TE times DT. That's our last step here. Product of And there's no shorthand here. Sorry, suck it up. Product of the means equals product of the extremes. All right, so we only have one more to go. So everyone see the 3 steps that you need there at the end. You can't skip a step. Triangles are similar, the proportion, cross multiply. All right, all good? We got one more to go. Let's do it. Got a parallelogram. That's all really I gave you, a parallelogram. And then notice you're multiplying sides together. So this has got to be a means and extremes. So let's figure out the 2 triangles first. You need to prove similar. What's the first side up in the proof statement? 9, first side in the proof statement. QC. Everyone look at QC. Can you identify a triangle that's definitely got QC as a full side? It's a big one, huh? What's that triangle that has QC as a full side? Let's go 2.
QCR.
Here we go. Highlighted, everybody. QCR. Next one's QP, but does everyone see I got an issue with QP? It could be QPR or it could be QPB, right? Everyone see that? So QP is really not going to help me out here because it could be 2 different triangles. So let's keep going. AQ. Or I guess I didn't even see a 3rd triangle there, right? Everyone see AQ? Now put together QP and AQ. Everyone see the triangle? The second triangle? What's the second triangle's name? 4?
QBA.
Yep. All right, I need angle here, and all you know is a parallelogram, so you better think back to your parallelogram properties last unit. A couple ways you could go here. Ready for give me a pair of angles? Anybody see a pair of angles knowing it's a parallelogram that are congruent? Here we go. 10. Any angles?
R and P.
Okay. Just get a little more. I know what you're talking about. Get a little more specific, though.
Angle CRQ and QPS.
There you go. Those 2 right here, everybody. Good. Works for me. Angle SRQ congruent to APQ. What property is Iris applying here? 9, what property is she applying? Perfect. Opposite angles congruent in a parallelogram. Good job, everyone. Good job. All right, where's the other pair then? Where's the other pair of angles in the orange and the yellow triangle there that are going to be congruent? You could give me 2 different ones for the same reason. Anything? 1, Anna, anything?
RQC and PAQ.
PAQ. All right, yep, that's true. You could have given, hey, take a look. You could have given me angle C in this one for the same. What type of angles are these that Anna just gave me? What type of angles? 7, what type of angles did you just give me? Alternate interior. Hey, whoa. Hopefully we're not writing they're congruent in step 3 because they're not congruent yet. We've gone over this, I think, last week. These aren't congruent unless I know what about the lines. 9, I got to know what about the lines. They're parallel, so that's what I got to write in step 3. And I think we talked in here, if you're ever confused what lines to write are parallel, just write both. All right, you're not wrong, just write both. All right, is it going to be RQ and SP? Is it going to be QP and RS? If you're confused, write both. Can't go wrong. All right. In this case, with these two, it's going to be RQ with PS. But again, if you thought it was the other pair, write both down. You can't go wrong. Parallelogram implies opposite sides parallel. Now you can say the alternate interior angles are congruent. There you go. So angle RQA is congruent to QAP. What's that reason? A little midterm review. 5, what's that reason that they're congruent? He's got 5.
Oh, shoot.
Hi, how are you?
Let's see. Alternate interior angles.
Need something more than that.
Oh, parallelogram.
Yeah.
No, parallel lines implies alternate interior.
There you go. Need that. That's it. They're not congruent unless they got parallel lines. And then here you go. Give me a good similar statement now. Triangle. Who's got it? Oh, 8. Triangle.
Triangle CRQ.
Okay, name that any way you want. Similar to.
Similar to triangle QPA.
I like it. Angle, angle. Now remember, I can't go to means and extremes unless you have a proportion to cross multiply. Don't skip it. Use your proof statement to build the proportion. Go ahead and I'll ask somebody your proportion. $12, can I get your proportion?
I did QC over CR.
Yep.
Then AQ over QP.
QC times QP. All right, looks good to me. As long as you're cross multiplying what's in the proof statement. And why are the sides in proportion 11?
CSSGP.
And then we got means and extremes. There you go. Questions? We're all good? Okay, you guys are gonna, I know we didn't do any algebra questions in class. I didn't feel the need to, but be prepared. You're gonna do some algebra questions tonight. Have your Chromebooks out, please, too. I want the answer key open, too, as you do these, so you know you're doing them correctly. Let's go do your Chromebooks. Get the answer key open on Classroom, because you guys have 21 minutes, about 11 minutes still. Plenty of time. Actually, no, I can't even do that. 17 minutes. Yep. So I want you checking your answers as you go along.